Hi folks, it's Mr. Ackerman here. The video that you are now watching deals with a topic called significant figures, or affectionately known as Sig Figs. This is part one. There's going to be a second video. In part one, we're going to learn what are these things called Sig Figs and how do we count them. Now, probably I can give you some idea of what we mean by Sig Figs, like what they are, by starting off with a little story. And here's the story. I'm just going to make this up, but I think it'll serve to illustrate the point. Suppose in the year, I don't know, 2008, just to pick a number, suppose in the year, whoops, let me just get some drawing tools here, there we go. Suppose in the year 2008, you found a really, really old painting, and you didn't know when the painting was completed, but based on a number of factors, you decided that it was, I don't know, a couple hundred years old, okay? Maybe you took it to an art dealer who was able to look at the quality of the paint and the way that it was done, and could tell that, yeah, this thing would have been painted like 200 years ago. Okay, fine. Now, of course, right now it is 2013, so it's plus 5 years. So imagine that you took this painting to your friend and showed it to him. And you said, hey, I got this painting that I found 5 years ago. I took it to an art dealer. He said it was a couple hundred years old. Now, if your friend said something like, wow, that makes it 205 years old today, what would you say? On the one hand, he's not wrong, because if you said it was a couple hundred years old and that was 5 years ago, then now I guess it is 205 years old. However, keep in mind that when you got the initial estimate of a couple hundred years old, that was just someone's opinion. There's no way of knowing for sure when it was made. It's just an estimate. So to take an estimate where we're not really sure how precise and accurate it is, and then to add something very well known, like the 5-year difference between 2008 and 2013, and then say something like this, that should strike you as a little odd. Maybe your friend didn't think through carefully enough what the situation was. Well, if you can appreciate the story that I'm telling you, then I think you're going to understand what we mean by significant figures, or Sig Figs. Basically, what Sig Figs are is this. When you have a number, such as the age of something, or it could be the mass of something that was weighed on a scale, or it could be the distance of something measured with a ruler, and you quote a number, each of the digits in that number have a certain meaning. If the meaning is exactly what they seem to suggest, then we say they are significant. And if they're just kind of weak estimates, then we say they're not significant. So when the art dealer said a couple hundred years old, he probably meant something like, well, you know, it's not 100 years old because art changed in the last 1 to 200 years. And maybe he also knows it's not 300 years old. So he could rule those out. Maybe he could look at how the paint had worn out over the years. But there was no way that this art dealer was capable of saying, hey, I know it's more than 199, and I know it's no more than 201. So take that to the bank, my friend, 200 years, bang on. That's what we're getting at here, okay? So from now on, whenever you see a number quoted, you have to start thinking to yourself, how many of the digits or figures in it are significant? In this example over here, what the art dealer is really saying is, well, you know what? Only one of the numbers is really significant. I don't know to the nearest single year or even decade when this thing was made, only to the nearest 100 or so years. So I'm confident about that number, but I'm really not sure about these numbers. We call this a 1 Sig Fig number. On the other hand, in another situation, the art dealer might do a very good job of pinning down to the year how old that painting is. And now he's telling you that yes, the 2, yes, that 0, and yes, that 0 are all significant. This example would be what we call a 3 sig fig number. SF is what I'm going to use for shorthand notation there. All right? So now you know what are sig figs. And so the question is, if I give you any number imaginable, how do you tell me how many sig figs there are? Well, there are certain rules you can follow that'll make it really, really easy to say how many sig figs. Let's have a look at these rules now. I started off with a couple examples here. I was talking to you about measurement, and one of the measurements we can make, of course, and that you will make in a physics class, is mass. Let's see how good you are at counting sig figs. Here's a bowl of raspberries. The bowl and the raspberries on this scale say 235 grams. What is the scale telling us? Well, the scale does read to the nearest single gram, so what it's telling us is that it doesn't think that the number is this low, otherwise it would have read 234. It's also telling us that the number's not this high, otherwise it would have read a number that high. In other words, it's telling us I'm confident about the 2 as in hundreds, I'm confident about the 3 as in 30s, and I'm confident about the 5 as in 5 grams. In other words, this once again is a 3 sig fig number. Here's another example. You take some, I don't know if these are earrings or what, maybe a little bracelet or something, and you put it on a scale, and this is the number you get, 45.22 grams. Now this scale here reads to the nearest hundredth of a gram, whereas this one only reads to the nearest single gram. Now I got to tell you, you're probably going to pay a lot more money for a scale that has this level of precision, so that's one difference. It's also a lot more sensitive than this one over here, and so they have different uses. But getting back to what this number really means, this is telling you that the scale believes that the mass is not so low as 45.21, otherwise it would have said that because it's quite capable of saying that in the ones column. Also, the number is not as high as 45.23 grams because otherwise, for the same reason, it would have said that. In other words, it's confident that the 4, the 5, the 2, and the 2 are meaningful, significant numbers. There are 4 of them, so this is 4 sig figs. All right? You may have started to get the idea that pretty much any digit that's written is significant. And this takes us to our first rule. I've only given you numbers 2, 3, 5, 4, and so on. The numbers here, I haven't given you any zeros. So let me bring us to our first rule, which is this one up here. All figures 1 to 9 are significant. Any number that you see that has digits 1 through 9, you count each of them as being significant. So just like we did back here, these are all digits 1 through 9. They fall into that category, 3 sig figs, 4 sig figs. Going back here, here's a little bit of a difference. I got some zeros in here. Let's see how we deal with zeros. So, second rule. Zeros that are in between significant figures are also significant. So, as an example, if I gave you this number, 2,305, then the 2, the 3, and the 5 all fall under this category of digits 1 through 9. So there's 3. And here's a 0 that's in between 2 other significant digits, so it counts. This is a 4 sig fig number. Okay? Here's another one. 9308572. How many significant digits? Well, here's a 9, a 3, an 8, 5, 7, and a 2. They all fall under this category, so they count. 1, 2, 3, 4, 5, 6 significant digits. Here are zeros that are in between other significant digits, therefore they count. In the end, we've got 3, 4, 5, 6, 7, 8. So 8 significant figures. All right, so that's the first rule about zeros. If they're between other significant figures, they also count. All right, but there are more places that you can encounter zeros. Let's take a look at some. Zeros can be at the end of a number that has a decimal. For example, you could have the number 23.050. How many sig figs are in this? Well, following the rule that we learned back here, digits 1 through 9 count, and zeros in between significant figures count. Well, that means the 2 and the 3 and the 5 for sure. Here's a 0. It's in between two significant digits or figures, so that counts. Don't worry about the decimal here as far as this 0 is concerned. This 0 falls under the rule of in between other significant digits or figures. But here's an ending 0. It's at the end of a number that has a decimal in it, and therefore they are significant. So this one actually has 5 sig figs. And if you're wondering how do you see that, well, think again like a scale. If you were a scale and you measured this number of grams, what you'd be telling the person that was reading the mass is that you didn't believe the number was a bit lower, and you didn't believe the number was a bit higher. Otherwise, you would have said so, because your digital readout can display this column, the 1,000th of a gram column. Therefore, this is a 5 sig fig number. Okay? Moving on to the next rule about zeros. Leading zeros are never significant. Now, what is a leading zero? When would you ever have a 0 in front of a number? Well, here's one. 0.0052 of a gram. What is 0.0052 of a gram? Well, think of it this way. If your scale reads this, it's telling you that the number is not 0.0051 of a gram, and this number is not up here 0.053 of a gram. Otherwise, the scale would have said that. Therefore, the 2 and the 5 are definitely significant. After all, they fall under the category of 1 through 9. But what about the leading zeros? These are the leading zeros here. They are in front of the significant numbers. Well, how to think about these numbers, I'll give you a hint. Use your skills of using scientific notation. How would we write this number in scientific notation? Easy. You would go 5.2 times 10 to the 1 to negative 3. And now what do you see? You see this. A 2 sig fig number. And so guess what? Whenever you have leading zeros, as in a decimal, and you just write the number in scientific notation, you'll instantly find out how many sig figs there are, because this is where that number is contained. There's no zeros that go in front of this. As for this part here just tells you where the decimal place is, so it has no bearing on how many sig figs there are. Okay? There is one final time that you're going to encounter zeros, and I'm going to show that to you now. And this one is a real pain in the neck. Everyone gets confused about this, and they always tell me that there's different rules in different places, and they're kind of right. Students have a right to complain about this. A whole number ending in 0 is a pain in the neck. Let me give you a for instance. Let's go back to the art dealer who told us that our painting was 200 years old. Did this art dealer mean, I don't know, it's not as low as 100 years old. I would recognize it as being different if that were the case. And it's not 300 years old. It would look a lot more worn out, and the style of the art would be a lot different. The best I can do for you is tell you 200 years old. Or did the art dealer mean, you know what? I think your painting is 200 years old because 190 years ago they were making paintings that were different. So it's not 190 years old. And for that matter, 210 years ago, the paintings were different still. So I can narrow it down to the nearest decade. Or is this a really good art dealer who knows her stuff, and she says, I can tell you to the year what age that painting is. A year before and a year after, year after and a year before, things were so different that I would be able to distinguish it. Which one are we talking about? Well, if you are talking about this one, then this is, of course, 1 sig fig. The 2 is significant, and these zeros, because of the context of the discussion you're having with your art dealer, they don't mean anything, they're just guesses. Here, you'd be talking about 2 sig figs, because, again, we're telling you, yeah, the hundreds and the tens column are known pretty well. It's the ones column we're not sure about. 2 sig figs over here. And, of course, this, for similar reasons, would be 3 sig figs. So I hope you can see that anytime you have a whole number ending in 0, 200, 200, and 200, it is unclear what we are dealing with. And so I really hate it when textbooks write these kinds of numbers. So what do? Well, first of all, if you read the very beginning of your textbook, the part that no one ever reads, it might say something like, in this textbook, whole numbers ending in 0, we want you to count none of the zeros, in other words, just the digits 1 through 9 is significant, or we want you to include all of the digits, in which case you count the zeros. So see what your textbook says. Your teacher will probably also have a way of doing it, and so you ask your teacher what she says, and she'll tell you, and you just follow those rules. But I have an even better way where no one's going to be confused, there will be no lack of clarity. Here's what you do, folks. You use scientific notation. Let me show you how you can use scientific notation to clear up the whole problem. If you want the 200 to have 1 sig fig, then write it this way. Done. 1 sig fig. Remember, this doesn't count for sig figs, it just tells you where the decimal place is. If you want it to have 2 sig figs, then just write it like this. 2 sig figs. And if you want it to have 3 sig figs, then write 2.00 times 10 to the 2. No one will ever disagree that this is 3 sig figs, this is 2 sig figs, and that's 1 sig fig. People will disagree if you write whole numbers ending in 0 like this. Okay? And that brings us to our final topic, which is some special cases. So there are 3 special cases that I need to talk to you about. Kind of funny numbers where you're not quite sure what to do. The first one would be something that I call counted numbers. What do I mean by a counted number? Well, I mean exactly what it suggests, counting. Suppose you count all the students in your class. You go 1, 2, 3, 4, 5, 6, and so on, and you get up to 25 students. Well, I ask you, how many sig figs in here? Is this a 2 sig fig number? If you said 2 sig figs, then what you're basically saying is, I'm confident about the 2 and the 5, but I have no confidence beyond that. In other words, it's not 3 sig figs, 25.0, that would be 3 sig figs. It's not that. And I'd ask you, why are you not sure whether this is the answer? And you'd say, well, because I'm really not sure if there are fractions of a student in the class. Like, I don't know, maybe someone left some body parts behind or some have been taken when no one was looking. A 3 sig fig number here would mean this. Fractions of a student, fractions of a person? No, 1 person in each seat. So you don't mean 2 sig figs, 3 sig figs, 4 sig figs. It's a counted number. It's exact. There are exactly 25 students. So counted numbers have, you could think of them, 25 students, as being this. 25.0000 going on and on forever, as in not a question, exactly 25 students. It's got an infinite number of sig figs. So if you're ever using counted numbers, they will have infinite numbers of sig figs. They are exact. Here's another example of an exact number. It's a number that I'll call a definition. For example, the formula for the area of a triangle is a half base times height. You plug in the base, you plug in the height, you multiply. These are measured numbers. They'll have significant figures, but does the 1/2, which is really 0.5, does it have one significant figure? Well, no, because the area of a triangle comes from imagining two triangles, as in a rectangle, and then dividing it in half and getting your triangle. That's why you do, here's the base, there's the height. Base times height gives you the whole rectangle area. Now take exactly, right, exactly half of that and get the area of a triangle. Once again, it's an exact number, so it's also got infinite number of sig figs. Okay? And the final example would be something like pi. You go look up pi online, you get something like this, 3.1415926. That's all I memorized from my calculator. I got bored at this point. But this number goes on and on and on forever. There are computers working out this number as we speak, and I don't know what digit they're on, but they know to all of these digits how many digits that are significant, sorry, figures that are significant are in pi. So numbers like pi, numbers that mathematicians work at a lot, they have lots of sig figs. You will never have to say, oh, it's only got 3 sig figs or 4. Numbers like pi have lots and lots of sig figs. They're almost like the definitions, which have infinite sig figs or counted numbers that are exact. All right? So I hope you know now how to do the following. Explain what sig figs are and count them in any number that I could give you. In part 2 of the video, remember this is just part 1 that you're watching. So in part 2, we're going to learn what you do if you have a bunch of numbers, each of which has its own number of sig figs, and you have to multiply them or add them or divide them or subtract them, because there are rules to follow. So if you now understand what sig figs are and how to count them, go on to the next video and learn how you deal with sig figs during mathematical operations. All right, thanks for watching, everybody. Have a nice day, and I will see you in a future video. Bye now.